A solution is made up of two components. Okay, so in a solution, you have a solute and a solvent. So assume this is a beaker which consists of sodium chloride, that is carbon salt, and water. The solute would be NaCl, that is sodium chloride, and the solvent is water. So the substance which is present in less quantity or in less amount is the solute, whereas the one which is present in an excess quantity is called the solvent. So the amount of solute in a given quantity of the solvent is expressed as concentration. So how much amount of solute is present in that particular amount of solvent is given, that's given as concentration, and there are various ways by which we will be we can show the concentration of that particular solute in the solvent. So in this video we will be learning the various ways of expressing concentration. So there are majorly, like you have four, that is mass and volume percentage. The second would be the molarity, third is the molality, fourth is the mole fraction. So we will be studying about all of these. The first one we will be studying about is mass percentage. So mass percentage is used when you have a solid solute basically. Okay, so it is the mass of component per 100 grams of the solution. So mass percentage of A equals to WA by WA plus WB into 100, where WA is the mass of A and WB is the mass of B. So suppose you have a 10% weight by weight solution of NaCl. Okay, this means that you have 10 grams of NaCl in 90 grams of water. Okay. So here weight by weight, so you have a 10% weight by weight solution of, or rather mass percentage of NaCl, then 10 grams of NaCl is present in 90 grams of water. Now let's do a numerical. A solution is prepared by adding 2 grams of a substance to 18 grams of water. So we need to calculate the mass percentage. So mass percentage is equal to the mass of A divided by mass of the solution. I'm just abbreviating it to this, into 100. So this is equal to 2 grams divided by 2 grams plus 18 grams into 100. So the units of grams getting cancelled, leaving behind a percentage unit of 10%. So here the solution has 10% of the substance. So mass percentage is denoted as W by W and its formula is WA by WA plus WB. The next one is volume percentage. So this is mainly used when you have one particular liquid dissolved in another liquid. So it is the volume of the component per 100 parts by volume of the solution. So volume percent of A would be equal to VA by VA plus VB into 100. So VA is the volume of A and VB is the volume of B, and it's denoted as V by V. There is also another one which is W by V. So when I say W by V, and this is weight by volume, and let's assume you have a 10% solution of W by V of NaCl. Here it means that 10 grams of NaCl is present in 100 ml of the solution. So remember one crucial difference. Here if it was W by W, then it would have been 10 grams of NaCl in 90 grams of water. Whereas in the W by V, Here if it is 10% of NaCl, then it is 10 grams of NaCl in 100 ml of the solution. Okay, that's one important difference between these two. So we have a numerical again. So if 10 grams of oxalic acid is dissolved in 500 ml of the solution whose density is given, what is the mass of, what is the mass percentage of oxalic acid? So here we have 11 grams of oxalic acid dissolved in 500 ml of the solution. So we've been given density. Density equals to 1.1 grams per ml, and density is also equal to mass by volume. So here you have value of density as 1.1 grams per ml. So the mass of the solution will be equal to the density into volume. So density is 1.1 gram per ml into 500 ml. So ml and ml will get cancelled, leaving behind grams. That is equal to 550 grams. So we have the mass of the solution 550 grams. So we know the mass of oxalic acid is 11 grams. Right, so we've been given the mass of the oxalic acid. So mass percentage of oxalic acid would be equal to the mass of oxalic acid, that is 10 grams. One moment please, I think it's, I'm so sorry, here the question is 11 grams of oxalic acid. So 11 grams divided by 550 grams, because that's the mass of the solution, into 100. So these two will get cancelled. 11 5s are, 5 2s are. So basically simplifying all of this, you get 2%. So first we have to calculate the mass of the solution from its density, and then we calculated the mass percentage of oxalic acid. So this is about volume percentage. There is one very important thing called as parts per million. When there is a particular substance which is available in very trace amounts, we use the term parts per million. So parts of a component per million parts of the solution. So it's very less amount of. So what happened was there was a lot of confusion because the decimal point led to a lot of issues. So the scientists decided that there'd be another unit called parts per million. So parts per million of A is the mass of component A divided by the total mass of the solution into 10 to the power 6.